I'll say it again. So, on graphing rational functions, I am not going to be picky about ordered pairs or really what anything looks like. Hello.
How many do you have? 2?
So the main thing when you're graphing a rational, or how do you identify that it is a rational function? We talked about that last class. It's a fraction, and what has to be on the denominator? An x, or just some sort of variable. So that's how I identify that it is a rational function. So the parent function, which is just the most simple form, is y equals 1 over x. So the things that I'm going to be asking you to find are domain range, vertical asymptote, horizontal asymptote. And then in a few examples, we'll get to finding x and y intercepts. And there are little tricks that you must memorize in order to graph all of these things. So the rule for domain is that it's going to be all real numbers. So if you're reading it from left to right, it's going to be all real numbers except your vertical asymptote. So that's what VA stands for. So if you're reading it from left to right, it's going to be defined everywhere. It's going to stop at your vertical asymptote, and then it's going to pick back up immediately after that and go to infinity. So if you're doing it in interval notation, negative infinity to whatever your vertical asymptote is, union, remember the U, and then vertical asymptote to positive infinity. And it has parentheses because it never touches the vertical asymptote. It never touches it. And rule for range is the same thing. It's going to be all real numbers except your horizontal asymptote. So negative infinity, horizontal asymptote, union, horizontal asymptote, positive infinity. And you read range from bottom to top. So to find your vertical asymptote, it's the same thing as talking about your excluded zeros or your excluded values on the last unit. So in 9.4 we talked about excluded values. It's the same thing as what your vertical asymptote is. So you're setting your denominator equal to 0. And so in this example, I would say x equals 0. For this type of graph where you have a number on top and just an x on the bottom, your horizontal asymptote is going to be whatever is out to the side, if you had like a plus or minus something. And there's nothing there, so I'm going to say that it's y equals 0. So I'm going to draw, make this smaller, I'm going to draw my asymptotes. Now, where the function goes, if you were to graph this in your calculator, all rational functions are diagonal of each other, like they go in diagonal quadrants. And if it's positive, they go in quadrant 1 and quadrant 3, like this. It's not the best picture. And like I said, I'm not going to be too picky about points and ordered pairs. However, it might be helpful to do 1 or 2 ordered pairs just to see which quadrants they go in. So for instance, if I made a table, if I were just testing x equals 1, 1 over 1 would be 1. So I have a point here. So my picture's, not the most accurate, but I told you guys I'm not going to be picky about ordered pairs. Yes. If I put in -1, then I would get -1. So you're just testing to see which quadrant they go in, but the parent function's always going to be in the quadrant 1 and quadrant 3. And rational functions always get really close to your horizontal and your vertical asymptotes. Like they always are kind of tracing it. So they're always approaching those asymptotes. So how do I know which way to draw them? They're always getting close as your end behavior is extending. So as you're getting further and further away, it's getting closer. It's kind of outlining your asymptotes. And it's going to be that way for every single equation. So you'll kind of get in the habit of knowing how to draw it. So if it's a non-calculator, then just seeing which quadrants they're in and then tracing the asymptotes. But if you do want to plug it in your calculator just to kind of see what it looks like, then you can. And domain is going to be negative infinity, 0, 0, positive infinity. Same for range. So the numbers that go here are your vertical and horizontal asymptotes. So there are two types of rational functions we're going to learn how to graph in 9.2 and 9.3. When you see a function that looks like this, and it asks you to do transformations, this is when you have a number on top and an x on bottom. So the rules are different for number on top, x on bottom, than they are for when we do another example or we look at the second kind when you have an x on top and an x on bottom. So you'll use transformations to graph this kind of graph, and then there are separate rules that we'll learn here in a minute. So the transformations are the same as what we've been doing. And so A is going to be your vertical stretch or compression. And it would be a compression if you had like a 1 over 2x or something like where you had a fraction where the number was on the bottom. Something like that. I haven't seen too many compressions though. They're mostly just stretches. Then your vertical asymptote, you're going to switch the sign. And then your horizontal asymptote is your last number, and you're going to keep the sign.
So is the x or the h the vertical asymptote?
It's the h, but your vertical asymptote is always an equation of a line. So it's always a vertical line, x equals and y equals. That's also a good point. When you're doing these, I haven't been as picky in the past, but when you say vertical asymptote, it's always an x equals equation. And a horizontal is a y equals. And if you forget those, then there will be points taken off because I don't know if you're talking about a x equals or y equals equation. But you cannot just put 4. You have to put x equals 4. And also if you have a negative in front, then that's going to be reflex x-axis. So let's look at number 2. What are the transformations for number 2? It reflects x-axis. What does the 4 tell me? Stretch by 4, so vertical stretch by 4. What does the x plus 2 tell me? A vertical asymptote of 2, and the right, left, up, down rules still apply. So if it's x plus 2, does that tell me it goes to the right or to the left 2? Left, because it's opposite sign. And the minus 1 tells me down 1. So what I'm going to do is I'm going to start at 0, 0. I'm going to go left 2, down 1, and that's kind of the point where my vertical and my horizontal asymptotes cross. So I've got a vertical asymptote at negative 2 and a horizontal at negative 1. So I'm going to label those. X equals negative 2, y equals -1. And then I'm going to draw my picture. So in the original one, it was in the top right and the bottom left, so quadrant 1 and 3. Because y'all remember 1, 2, 3, 4 quadrants. Just a little refresher. So if you just have a plain Jane equation, it's 1 and 3. If it reflects the x-axis, imagine flipping it, it's in quadrant 2 and 4. So your picture looks like this. Like I said earlier, I will not be grading ordered pairs. All I care about is horizontal, vertical asymptote, and which quadrants you're drawing the picture in. So since it reflects, that means that it's opposite. So imagine taking your graph and flipping it. That's kind of what we did. So if you look at the original, it was in 1 and 3, flipped it, 2 and 4. But also, if you like to make sure that you are 100% correct, like I said, you could test ordered pairs and see where the picture is. So my suggestion usually is using like x equals 1 or 2, something easy, just to kind of see what quadrant it's in. But I will just be checking that your graph is in a certain quadrant. I will not be checking any ordered pairs. Like my picture could be kind of wrong. That's okay. So for domain, it's -infinity. Where does it stop? -2, union, -2, positive infinity. My range, it's -infinity. Where does it stop? Good. -1, positive infinity. Video. So this one does not have an x in the numerator. It looks like this. It has a 4 in the numerator. And then it has stuff out to the side. The next one has an x in the top and the bottom. Yes. Oh, holes. Okay. We'll talk about that. There are none here. Let me see if I can go back. There it is. Holes are when, I'll just put the definition out, but we won't see any for a little bit. Holes are when you have, so when you're simplifying, like this is why I did this section before, or 9.4 before I did this section. Holes are when something cancels. So when factors cancel. So for instance, if I had, let's say x plus 3 over 2x, x plus 3. And so you won't really have any holes for this kind of equation. That's why we haven't seen any yet, but we will in the next section. But if I had this example, the x plus 3's would cancel and you would have a hole at x equals -3. So you just set it equal to 0, and that's where a hole would be. So holes only happen when something cancels. There are none for this example because nothing canceled. It only happens when you have an x on the top and an x on the bottom, when something cancels. Okay, so if we go to the next problem, here are the rules if we're not using transformations. So we're not given like only a number on the top, x on the bottom. So if we have x on top, x on bottom, we don't do transformations for that because it doesn't lend itself to being easy to doing that. So here are the rules. You must memorize these, but I think that once you do 1,000 examples like we're going to do, you'll kind of just, it'll be second nature. So there's 4 things I'm going to ask you to solve for. Vertical asymptote, horizontal asymptote, x-intercepts, y-intercepts. And I'm going to try and make this as simple as I can without so many words. Vertical asymptote, you just set the denominator equal to 0. We already did that one. So set denominator equal to 0. That one is easy. The horizontal asymptote, I think, is the most difficult part. You have to look at the degree of the top and the bottom. What does degree mean?
Exponent.
The exponent. So if I had an x squared, my degree would be 2. If I had x cubed, my degree would be 3. If I just had an x, my degree would be what? 1. So looking at the degree. Now, there's a little acronym that has helped people in the past, and it sounds kind of weird, but I think it's going to help you. So I want you to write this. Bobo, Botten, eats, DC. So just write that down and then I will explain it. And so what you're doing is you're comparing the degree to the top and to the bottom. And there's 3 outcomes that could happen. So if your degree is bigger on bottom, so bottom is bigger, so that's what the Bobo stands for, bigger on bottom, then it's y equals 0. Bobo, bigger on bottom, 0. If it is bigger on top, then you have none. And you have what is called a slant asymptote, which we'll talk about in 9.3. So bigger on top, bottom, none. So far we have bigger on bottom, 0. Bigger on top, none. If they are the same, then you look at the numbers and the coefficients of the numbers in front, and that is the ratio. So that should say ratio of leading, not ration. So what eats DC stands for is exponents are the same, divide coefficients. So this is divide, coefficients. And it really just takes examples for that one. But we'll look at some. So Bobo is what? Bigger on bottom, 0. What is Botten? Bigger on top, none. Eats DC. Exponents are the same. Divide coefficients. Good. So that is horizontal asymptote. X-intercepts, you set the numerator equal to 0. And then y-intercept, you set x equal to 0. So there's 3 things you're going to set equal to 0. Numerator, denominator, x. And then you're going to do the Bobo, Botten, eats DC thing. So those are the 4 things you will do for equations like this. So here we have 2x plus 1 over x minus 3. The first thing you want to do is try to simplify first. Nope, that's not how you spell it. Simplify. Simplify first to check for holes. So for instance, if I could cancel anything out, then that would make life easier and I would know that I have a hole. But most of the time it's going to be in its simplest form. I will say that. So for vertical I just usually out to the side, I put VA, HA, X, and Y. So I know that those are the 4 things that I'm going to do. So for vertical asymptote, I do what? You set denominator equal to 0, so x minus 3 equals 0, so x equals 3. For horizontal asymptote, I'm going to look at my two leading degrees. Now, the degree on the top and the degree on the bottom are what? 1. They're both the same. So, that means that my horizontal asymptote is divide coefficients, 2 over 1. So, y equals 2. It's just the numbers in front. And if it's a fraction, that's okay. It could be like 1/3 or something. That's also okay. X-intercepts, what do I do? Set numerator equal to 0. So x equals -1/2. So -1/2, 0. And then y, what do I do for y? Set x equal to 0. Both of them. So it's like saying 2 times 0 plus 1 over 0 minus 3. So you're plugging in 0 both parts. And so you end up getting -1/3. And I want x and y intercepts written as an ordered pair. Okay, and then are there any holes? Did anything cancel? None. So now I'm going to go to my picture, and I'm going to draw the vertical and horizontal asymptote. I'm going to plot my x and y intercept, and then just connect the dots, or draw my picture. So 0, negative here. So these are my 2 points. They're going to go towards the asymptote, and they're always in opposite corners. So I just it does not matter how I draw my second part. I just know that it's going to be diagonal from the one that I have. So plot your x and y intercept, and then put your other one in the opposite corner. And then domain, -infinity to where? 3. And range, -infinity to 2. Okay, so vertical asymptote at -1, horizontal asymptote at 3, because they are the same degree. So the coefficients divide, -3 over -1. And no holes. Domain, all real except vertical asymptote. Range, all real except horizontal asymptote. I just plotted my x and y intercepts, and then I didn't care about the other ordered pairs, but just knowing that they are in opposite quadrants. And it's flipped because of the negative sign. So it's in quadrant 2 and 4 now because of the negative. So it does flip. Okay, let's look at the last one, number 5. So it says write an equation of the parent function. So this is automatically going to be one of those where it has a number on top and an x on bottom. It has a vertical asymptote at -2 and a horizontal asymptote at 5. So I want to rewrite this. If it has a vertical asymptote at x equals -2, then what would my denominator be? So this is my vertical asymptote. If I'm thinking about the rules of transformations from the last page, it's when I set my denominator equal to 0. So what would my denominator be if my vertical asymptote's at -2? X plus 2. Good, because it's the opposite sign. And my horizontal asymptote is the same sign, so what needs to go out to the side? Plus 5. Good. Good.